because what you're recreating is the horizontal plane that intersects with the dipping plane. So this line that you can draw underneath your compass is the strike line. That's not what you're measuring. You're measuring this direction, perpendicular to it. Later on in the handout is explained why we do that, because when we plot it later on, we don't work with strikes, we work with directions. Okay, so you measure the angle from north through east. And let's say in this case that is about 60 degrees, always in 3 digits. Direction is always in 3 digits, and the amount of dip is always in 2 digits. So as Dr. Bailey said, it is 30 towards 60. Now if you write it down the wrong way, with only 2 digits here, it becomes very confusing. You don't know anymore what is going on. So always, for the direction of dip, 3 digits. Now, if you have the same strike, but you have a dip in that direction, what do you measure? Again, that is north, that is south. You measure that angle. Now that is the power of the direction of dip method, because this is a unique number. There is no other interpretation possible than that the thing dips to the southwest in this case. So you would be here between 180 and 270, so that is probably about 300 degrees, 250. That would be about 250, and the dip, well, let's keep it 30, like that. So there you would write down 30 towards 250. Other people write it down like this, 250 stroke 30. Both are permitted. This one indicates quite clearly that it is direction of dip. Here you need to define it first that it's direction of dip. Now let's take one like this. Where we measure that angle, so that is more than 90, so that would be about, well, let's say 135 and 30, and you can have the same strike line like that, where we measure that angle, which now falls between 270 and 360. So that would be about 300. So that one would be, if that is 300 here, and that would be 30. So those are the various scenarios. Now you must always check that when you're in the field. Know where the sun is, or where the sun is supposed to be. If it's raining, it's difficult to see where the sun is. But you must always know where north is. The handout tells you which needle of the compass to read. You can't just take any needle, whatever your fancy is. There is a reason for that, and it must be the correct way to do it. And basically what you have is the pictures on page 4 for the Silva, and on page 3 for the Freiberger and the Kranz indicate that you've got the position of the compass body and the flap. This angle, it's called angle alpha. It is a cutoff when alpha is smaller than 90 or alpha is larger than 90. That is the difference where you read off the one needle or the other needle. And that is different for each compass because they're differently colored. The Silva compass also, you cannot stop the needle like you can with the Freiberger and with the Kranz. The silver you can't. The silver you have to rotate the entire compass face to align with one of the needles. And there you have two parallel red lines with an arrow on it, which must sit either over the red needle or over the white needle. And depending on the angle alpha, as it is explained here, you choose which needle to take. Okay, so why then do we measure direction of dip? Now, let's look at the practicalities, first of all. If you were to measure strike, now I'm going to do that in a different color. How would you indicate this strike line's position? Well, you can give it this angle. Now, there is no clear-cut way, so you say you start at north, and let's say that that angle is 30 degrees, because that one was 60. So you say north, 30 degrees, but you go west, colon, and then it dips 30 degrees. And now you've only got this line, and you know that the thing is dipping, but you don't know whether it's dipping in this direction or dipping in that direction. So now you say 30 degrees, in this case, east. If you compare that with 060/30, much less ambiguous and much easier. Also, you can use all these compasses that we have to measure the strike line. You set the thing open completely, so the flap is in direct, it's an extension of the compass body, and you use the long side of the compass along a strike line. So now you need to first establish where is my strike line. So you need to use the bubble to find the strike line. Then you have the orientation. It doesn't matter which needle you read in that case, because you still have to say north 30 degrees west, or north, what is it, 45 degrees east, or north 45 degrees east. But you see, you cannot distinguish in that way between these two. So, to avoid confusion, you record direction of dip, dip. Then, that is all explained on page 5 as well. And then we need to start plotting, which you will be doing from tomorrow. You see, to do an analysis of the deformation, you need a large number of data. You don't do it with 2 or 3 readings. That is not sufficient. So when you're on an outcrop, and an outcrop can be the size of this area here, the hole that we're sitting in here, that can be one outcrop. And you can take, between the 3 of you, you can take a large number of readings of the same feature. Whether it is a schistosity, whether it is a bedding plane, whether it is a cleavage, or a joint plane, doesn't matter what it is, you take a large number of it. Because they are never 100% the same. They're never all that consistent. There's always a couple of degrees difference in it. And what you do when you plot is you get a statistical analysis of the most frequently occurring orientations. And therefore the number is of importance. Now, if you have a stereo net, it's a stereo net, and you plot a great circle, so the plane. That's a plane that is dipping to the southeast, right? This would be the strike line. So this illustrates the dilemma you have when you work with strike. You get north, 30 degrees east, you put that point onto the north-south line and you draw the strike line, which when you rotate it back to north will look like that. Now you need to indicate which way it's dipping. It's dipping it's dipping in this case 45 degrees. Is it dipping to the west or to the east? It's dipping to the east. So then that is the dip. Now this point here, from there, that's the azimuth, or the direction of dip. Now you can understand that if you've got 100 of these lines on one diagram, you can't see the wood for the trees anymore. You've got so many of those lines that it becomes one black mess on your paper. So instead of using the plane, the great circle for the plane, we use the pole to the plane. Just one point. And that pole sits 90 degrees away. Now, as this distance is 90 degrees, and that distance is 90 degrees, it makes that this distance is equal to the dip. And this point is the same as that azimuth. So, what you do when you make these plots, when you plot poles, you start counting at the bottom. To plot poles, you start counting from 0 over there, in that direction, and you plot the azimuth, or the direction of dip. You then count from the center your dip, and there's my pole. So you don't have to first construct a strike line, then determine whether it dips to the east or to the west, or to the north or to the south, whatever way you want to express that, and then go 90 degrees the other way to get the pole. The direction of dip method, you start counting at the bottom, you get to the azimuth, you put that point on the east-west line, and from the center you count out what the dip is. So the system of taking the reading and the system of plotting your data on a stereo net is the same. It uses the same method. And that's why you save yourself a lot of time and a lot of calculations in your head when you are taking direction of dip readings. Okay. Tomorrow we can look at the diagrams and how you count it and contour it and that kind of thing, and how to do the interpretation. Any questions? Okay.
Before you head off, we just actually need you to collect the aerial photos for your area. Okay, so please get into groups, and then you can come and line up by the table, and we will give you an aerial photo, each person individually for your area. Okay. Group 1.